All right, so last day of class. Looking ahead, there's a mastering due tonight. If you haven't done it already, it's on chapter 19. And then we have our final. Then that's it. So what I was going to do today is go over some problems from the ACS exam, in the style of the ACS exam, I guess. And we'll just go ahead and, so you will need a calculator, paper to work on, and what I'm going to do is I'm going to put a few problems up here. I'll put a few problems up here at once, and then you can take your time working through them. Let's see if I can make this work. Okay, so we'll start off with some kinetics. Okay, so that's question 1. And then that's part 2. Feel free to discuss with people around you as you're working through it. Oh, All right, so in this problem, I have a reaction as 2A makes C plus 2D. I have a proposed mechanism. What do I call those individual steps? 2 words. One starts with an E. Elementary steps, right? I got 2 elementary steps. One's slow, one's fast. Which is the one that tells me about the overall rate? The slow one or the fast one? Slow one. So in order to figure out the rate law, I need to use the slow step. So which one of those is the correct slow step reaction for that? Nope, that's right. So what is B? We can answer question 2 first. What is B in these 2 reactions? So intermediate. Can we use an intermediate to put into a rate law? No, we can't. We can't put the intermediates in the rate law because as soon as it's added, then it's used up again. Oh, I see what Elizabeth's saying. Sorry, I do have the arrow in the wrong spot. That should be there. Sorry, that makes more sense. Should be A arrow B plus C. There we go. Sorry, I was trying to write them quickly. All right, so B is the intermediate. And A is the rate law. All right, let's try another one. That way it's less confusing. Let's try this one. So let's say I'll write a new one over here. All right, let's try this one. So I have a reaction where I have nitrogen and hydrogen makes ammonia. I have a proposed mechanism that the nitrogens break apart into 2 individual nitrogens, which is a slow step, and those 2 individual nitrogens go on then to react with 3 hydrogens in a fast step to make ammonia. What is an intermediate in this reaction? Right, nitrogen is the intermediate. Which one is the rate determining reaction, the slow step or the fast step? Slow step. So what, I would have K equals what? Good, good, okay. Okay, what if I have okay, I have this rate equation. So, one, it has to be experimental, right? And what do we do to find it experimentally? Do I change them both at once, change one then the other? Right, we have to do it, we have to vary systematically. All right, because you hold one constant, you change the other, then you go back and forth. So for example, let's say, it'll take me a second to write out this data table. All right, so here I have a table of experimental data, and I want to figure out what the rate law is for this reaction. Okay. Why is it not that? Where would I have gotten that information from erroneously? Right, I can't do it like that. I can't just look at the equation and get it from that. So your first instinct should be like, oh, I should probably use the table. All right, so if I want to look at how A changes, which 2 reactions do I need to look at? 2 and 3. What's going on with 2 and 3? Okay. What's happening to the amount of A? Doubles. What happened to the rate? So which order is it if it doesn't change? 0. All right, so then which 2 reactions do I want to look at about B? Okay, 1 and 2. What happens to the rate between 1 and 2? It doubles. So if it doubles, is it 0, 1, or 2? Right? I doubled this, and that doubled, so it's first order. So that would be the correct answer. I don't have to put any in the rate because it's to the 0 order. It's really 1. Oh, yeah, sorry. Okay. All right. What if I have, how are we feeling about rates? Good? Good on rates? Move on, do some more rates.
What's that second one? Why did you draw a second one? Just KB?
Because that's 1. Right. Yes, no. In the exam, this is a version of the exam. They gave you the data, they gave you a table, and there's multiple choice options.
On like the problem on the other page for the rate, why would you say K equals N2 and not rate? Like why was it K equals?
No particular reason. It should have been rate equals K. A little off my game today. All right. In that case, why don't we do some equilibrium? All right, so I have a solubility of barium fluoride, and I want to figure out the solubility product constant. How do I even start this problem? I would start by figuring out what the heck barium fluoride is, right? So barium fluoride, looking at your periodic table. Where's my periodic table? What letters is barium? Okay, where's that? What number? It's 56. So what charge should barium have? Plus 2. What about fluoride? What? Minus 1. So how many fluorides do I need? 2. All right, so I got BAF2. If I'm saying it's solubility, does barium fluoride start with a solid or an aqueous or some ions, or going to start as a solid? What does this now say to do? Now that I've written it, it is an ice table, right? It's a solubility table. So, what do I put in my change for bariums? Plus x, plus 8x, minus 14. Okay, what about my fluorides? So now I'm ready to set my solubility product constant. It's what over what? Blah over blah. Products over reactants. Good catch. Squared. And the bottom's a solid, so it's just a 1. All right, I'm seemingly stuck. What do I do next? It's 4x cubed. What have we not used that told us? And what is that in the problem? That is x. So you plug in for x and you find KSP. Good. Vaguely remember how to do that one? Let's see what else. All right, what if I have Okay, so which of the following makes a close to pH 5 solution? I have I got hydrochloric acid. I got benzoic acid. I got butyric acid. And I got formic acid. Why does HCl not have a Ka associated with it? So strong completely associates, right? Can't possibly have a Ka, because what does Ka tell me? It's dissociation, solubility, how much it makes in solution. So how do they go about figuring out which one of these is the best solution? You just need the Ka. The volumes they gave you is useless. I could, but HCl will never be pH 5. It just will always be. This is a bad answer. Strong acid won't ever be pH 5. What do we know about, what if I call this a buffer solution? At a buffer solution, what do we have? Conjugate acid-base pair and something equals something. Right, if I have a buffer, I have pH equals pKa. I gave you Kas. How do I get the pKa of each of these? Negative log of each of them. So if we did that, which one of those would be the best choice to make this pH 5 solution? Butyric acid. You could have spent your time doing an ice chart, solving for, but these problems are designed to be solved in 1 minute. They give you a lot of information, but there is, on a typical exam, 80 items, so 80 questions, and you get 110 minutes. So you need to be working through them about 1 a minute, maybe a minute and a half on some of the trickier ones. But they give you enough information that you should not spend very long calculating anything. You should spend most of your time being able to think it out and move on. All right, what if I have something like so I have CF3COOH and CiCOOH. Our options are so I have A, where the iodine version is more acidic because I is a large molecule. I have that they're equal. I have CiCOH3 because it's a heavier molecule, or CFCOH because F is more electronegative. Why would you choose D? what does electronegativity have to do with how that proton pops off?
So it's more likely to hold on to that hydrogen. So you want the other one to be a stronger acid because it more easily give up the hydrogen. You want to right.
Close. No, it is D. F is more electronegative, which means it is perfectly fine if that hydrogen leaves as a, right? Because we think about what it makes. The fluorine kicks off that proton and gets to keep the electrons. So it's very happy being a full-on -1. While this is true and this is true, those guys don't affect the ability of that proton to leave. So when you're thinking about which one's the stronger acid, whichever one has the more electronegative, it's happy being a full-on negative charge. Okay. What about we do? We'll do the pH of a weak acid. So what's the pH of a 0.15 molar benzoic acid solution? It is a nice chart. So benzoic acid, I'm just going to call it HA. It doesn't matter what it looks like, right? So if HA, when I have a benzoic acid solution, what is it reacting with? Water. What is one of the products I have to make then? If it's an acid, is it going to keep its proton, give it away, or take one more? It's going to give it away. It gives it to this guy, right? I get H3O plus, A minus. So what do I put in the initial column for my acid? What about these guys? Zeros. Plus X minus X, some other, okay. I got some pluses over here. What's this one? Yeah. So we're going to do the simplification that this is small. So let's double check. 6.1 times 10 to the negative fifth times 0.15. Square root that. Whoop. Okay, now what? Am I done? Do I circle that answer? No, because I want that's for the pH. So anytime you have these problems, make sure you're answering what they're asking. Because this is one of the answers. One of the multiple choice sections. That is a possibility. Because they're trying to trick you. But I want the pH. 003? Okay. Well, I got an error in my domain, so probably I punched it in wrong. Times 0.15. Oh, there we go. Yeah, instead of multiplying, I divided. That's my fault. That times that. Yeah, common error. Yeah. Which, the answer we got, which was wrong, is also an option. So, they're covering all their bases. It is mean. It's just mean. A lot of it's going to be reading comprehension. Because a lot of these questions, as I was reading it, I was like, oh, it's definitely A. And I go back and I'm like, wait, it's not A. It's because there's the word not in there, or there's the word except. And so your gut maybe go for A because you read it and you're like, A is definitely true. And you go back, you're like, well, wait a minute. It asks for all the following are true except. Well, A is definitely true. So make sure you read the question and you read all the options to make sure. So let's have one of those reading comprehension questions. Let's say, all right, so I have a reaction that has a positive delta H and a negative delta S. If it's positive delta H, is that exothermic or endothermic? Endothermic, all right. If I have a delta S less than 0, is that good entropy or bad entropy? Bad. So I have lots of things working against me. If I have this and this, what is most likely the sign of delta G?
Positive.
It's most likely a positive delta G, so what is most likely the correct K? A. Which you could have gotten to just thinking through those two, but I think it's easier if you have H and S tell you about G. These two together tells me that delta G is also positive. So if delta G is positive, is it spontaneous in the direction it's written? No, not spontaneous in the direction it's written. So if the K is less than 1, do I have more reactants or more products? I have more reactants, which is what this is telling me, that this is not spontaneous as written, which means my K is not spontaneous as written. Okay. What about? So I have an equilibrium constant of 4.3 times 10 to the 20th at 25 degrees Celsius. Which is true for this reaction. So I have instantaneous, not spontaneous, spontaneous, not instantaneous, instantaneous, but cannot determine spontaneous, or spontaneous, but cannot determine instantaneousness. All right, so what letter is the equilibrium constant of our alphabet letters? Right, this is K. So if I have a K that's 4.3 times 10 to the 20th, is it spontaneous? Well, does it tell us that's moving towards products or is moving towards reactants? Right, moving towards products. Does that tell me about spontaneity, or what's the word I should use instead of instantaneousness? Rate. Right, instantaneous tells me about the rate. And spontaneity tells me about equilibrium constant. So I know if I have a K greater than 1, that tells me about spontaneity. So which two are possible at this point? All right, B and C, because I know it's spontaneous. Do I know anything about the rate of this reaction? Does it tell you anything about rates or little r's? Or so can I know anything about its instantaneousness? No. Okay. What if I had At equilibrium, which is the true statement about Gibbs free energy? Which one of these is automatically wrong? A and B are definitely wrong, right? Because we know at equilibrium definitely something about 0 and G's. It is C. Why is it not D? How do you figure out, if I ask you just for a delta G with a standard state 0, you can look through your equations, right? So I have to have delta G, 0 is delta H minus T delta S. Well, that can't ever be 0. Or I have a table of G's. I can figure out products minus reactants. That can't be 0. So that is also a bad answer. If delta G is equal to 0, then we're at this point, right? Because we only relate those two. Right, this one. Oh, Q. There we go. All right. What if we have, we'll do some electrochemistry. Alright, so I have this reaction taking place in acid. You need to balance it and tell me the whole number coefficients in front of each.
SN4 plus.
Yeah. So how do we go about starting to balance these guys? What's the very first thing you need to do? Break them up into two halves. Which half do you want to do first? The chromium or the tin? Tin, because tin's easier. I would do that. Is this an oxidation or a reduction? Oxidation. All right, so where do I put the electrons? Has products or reactants? Okay, and how many do I need? 2. All right, so is this a oxidation or reduction? Reduction. All right, what is the oxidation state of the chromium over here? All right, so I have 7. What's oxygen always? 2. So I have 7 of those. So minus 14. If the whole thing is minus 2, what are these two guys? Plus 12, which means they're each 6. So I'm going from plus 6 to plus 3. How many electrons do I need to go from 6 to 3? 3. But how many chromiums? I need 2, so I really need 6 electrons. All right, is that balanced? Am I done? Not done. All right, so then, if I'm an acid, what are the 2 things I'm allowed to add? Water and protons. We always add the water first to take care of those oxygens. How many waters do I need over on this side? Okay, 7 waters. So then how many protons do I need? Now what? Can I just combine them as is? Yeah, multiply the top guy by 3. So then I'll have then it'd be like I'm mastering where it says, like, which is the correct to be 1, 3, 2, 3, or 1, 1, 1, 1, or Right, so you circle the right one that matches these guys.
I have a question.
Mm-hmm.
On, is it chromium?
Yep.
Okay, so when you balance the elements,
Mhm.
there's 2 each.
Yep.
They both have 6, so why do you need to add?
So, let me zoom in on just that guy. All right, so just looking at this part. So we decide that each chromium's plus 6. How many chromiums do I have on this side? Sorry,
Oh,
total number, right? I have two chromiums, so how many do I need over here? How many electrons do I need to go from 6 plus to 3 plus? 3. But then I have 2 of these.
okay.
Right, each chromium needs 3 electrons, so it's 6 total. All right, what if I had this question? All right, so this reaction, I have the iron ions is 2 molar and the copper ions are 1 molar. Are we at standard state? No, definitely not, right? Because what's standard state? Everybody has to do 1 molar, so now I'm not at standard state. So which one of these can we automatically eliminate? C, because they're not 1 molar. And D is just a bad answer, just bad, right. Have you ever found an E0 at 0? No. Mm-mm. All right, so then the question is, if those concentrations are not at standard state, I have more of this than that. How do I go about figuring out who is greater or less than? Either way, if I think about it. All right, so they're related. All right, we have that. So what would be Q for this reaction? How would I define Q? Products over reactants. So if I take the natural log of 2, do I input the number greater than 1 or less than 1? Less than 1. So I have less than 1 times 2. So this whole thing is going to be less than 1. So is E0 greater than or less than regular E? For the way I have it written. Yeah. For how I have it set up. That would be great. Which one? Yeah, A. All right, what if I had, in the last few minutes, we'll scoot along. What about, So I have this nuclear equation. What would the atomic mass be of this product? The same, right? Still 137. What is the number of protons? 56. Is that a new element? Yes, how do you know it's a new element? Didn't change weight. Change the number of protons, right? And that's the guy who decides if it's a new element or not. All right. What if I had what is the new mass of this guy? What's my new number of protons? Did I make a new element? Right, I still have the same element. How are these two related? Isotopes of each other, okay? Let's see. What else do I have? All right, so I got water and I got octane, CH18. Is this true? If they're immiscible, if they're both polar, could they also be immiscible? No, what does it mean to be immiscible? Right, they don't dissolve in each other. If they were both polar, would they dissolve in each other? They would. Bad answer. All right, what if I have no, what's wrong with that? What do you have to have when you do hydrogen bonding? Right, you have to have something electronegative stuck to it. Okay. What about what if they're just different densities? That tell you anything about their ability to mix? Okay. Also bad answer. Right, that's actually true. I mean, I think this is probably true. I don't really know about their densities. Let's see. Any questions from the audience, or I'll pick one more. Questions in general? Yeah, Kyle.
So what proportion is the Kim 108 going to be?
In terms of, there's a few, so this is technically Chem 108. So there's some questions about solubility. I'd say, I mean, it's small, it's a small proportion. There's also some questions about freezing point depression and boiling point elevation, which we did a little bit this semester, but you may have done in 108. Those guys, boiling point, freezing point. Yeah, you kind of already know some of those things. Molality.
So if we have that study guide, what section?
Oh, if you have the study guide, you need to study. Let's see here. In the states of matter and solutions section, just the last half really that talks about solubility, molality. We don't have to worry about body size or cubic or anything like that. So, diagrams like which of the following is a pure substance, or talking about this guy over here, what would be the pressure trapped by the gas. In the energetics section, pretty much the whole thing, the whole chapter called energetics. Because that's thermodynamics, right? That's all of our delta H, S, G. Yeah, there's no quantum numbers or anything like that. Dynamics, the whole chapter, because that's rate laws. Everything about rate laws. The whole chapter called equilibrium, because That's what we did this semester, lots and lots of equilibrium. The whole chapter called electrochemistry and redox, because we did that. And then there's always going to be a few questions in this section called laboratory chemistry, but they're usually fairly straightforward questions. For example, on this particular year's test, it was things like, let's find it. Which of the following should not go down the drain? Mercury chloride, sodium chloride, potassium chloride, magnesium chloride. Probably not the mercury chloride, right? So I wouldn't spend a ton of time studying the laboratory chemistry section. You know, which of the following is the best to measure volume? A graduated cylinder, a beaker, do it by eye, you know, a pipette. So things, they just want to make sure that there is a lab section of your course. So, all right. There is practice problems on my website also. Let me double check. No formulas, just lots of constants.